Hello everyone, my name is Bosan. Here is a video for our work PRN, Panoptic Refinement Network. So most panoptic segmentation methods do semantic and instance segmentation in different branches. The semantic segmentation mask is not consistent with instance segmentation mask. So here we are trying to refine the semantic and instance segmentation mask and make them consistent with each other. So we proposed the Panoptic Refinement Network, an encoder-decoder based network which can jointly refine the instance and semantic segmentation masks generated by any trained-based panoptic segmentation network. As shown in this figure, we design an encoder-decoder based refinement network which takes the RGB input, instance, and semantic segmentation masks from the first stage network as input. Our refinement network consists of 4 components. The first one is an input module. The second one is an encoder-decoder network for joint refinement of instance and semantic segmentation. The third one is a task-specific prediction branches for instance and semantic segmentation and also for foreground segmentation. The last one is a post-processing method guided by the predicted foreground mask and bounding box at each pixel. Based on these components, our refinement network can jointly refine the instance and semantic segmentation in a single shot. So the input to PRN comprises 3 parts: the RGB image, instance maps, and semantic segmentation map. All of these come from the base panoptic segmentation network. The input instance maps have 7 channels. The first 3 channels are represented by 1D center map and a 2D center offset map derived from the output of a base panoptic segmentation network. The pixels of the same instance should also be associated with the same bounding box. Based on this idea, we designed a novel 4D bounding box offset map which complements the center and center offset maps. As shown in figure, the 4 channels D1, D2, D3, and D4 correspond to the distance and offset from pixel to the top, bottom, left, and right of the instance's bounding box. The bounding box offset maps make up the last 4 channels of the input instance maps. We make some modifications to residual network and add decoder layers to build the encoder-decoder network. Our base panoptic segmentation networks includes the following 3 networks: DETR, real-time panoptic, and MS panoptic FPN, which is our modified version of panoptic FPN. We conducted the experiments on COCO and Cityscapes datasets. So here are some quantitative results on COCO validation set and on Cityscapes validation set. So here are some qualitative results on COCO dataset. So the first row is the output from our base panoptic segmentation results. The second row is our refined results from our PRN. So we can see that in the first row, the masks is not very good, like for the plane or the windows. They don't have a good mask. But on the second row, we can see that after the refinement, we can get a much more precise mask for each object and also for each stuff. Here are some qualitative results on Cityscapes. The first row is the input from our base network, and the second row is the output from a state-of-the-art refinement network, which is called segfix. And the third row is the result from our method. We can see that we can find the missing car and the missing person's mask in this image. That's it. Thank you.